Hi, I'm Patrick from Viberline, and today we're going to talk about three dial indicator concepts: total indicator reading, or TIR, the validity rule, and true position sensing. I'll zero my dial indicator at 12, and then roll it 180 degrees to 6 o'clock. It reads 30 mils, which represents the total indicator reading, or TIR. Now, as you're probably aware, the actual vertical offset of the shafts is half the TIR, or 15 mils. This is because when using a dial indicator to measure the relative positions of two shafts, the dial reads the misalignment on both sides of the center line, so the value comes up as twice the actual offset. The same is true if I zero the dial indicator at 3 o'clock and then roll 180 degrees to 9 o'clock. It reads 20 mils, the TIR, but the actual horizontal offset is half of 20, or 10. Next, to introduce the validity rule, let's set the indicator to 0 at 12 o'clock. Now we're going to take readings every 90 degrees for the full 360 degrees. We call this taking sweep indicator readings. So first, let's get a reading at 3 o'clock. There, we have 5 mils. Now another 90 degrees down to 6 o'clock. And that value is 30 mils. Next, we read at 9 o'clock, and that reads 25 mils. And then back to 12 o'clock, and the indicator comes back to 0. The validity rule states that when we rotate the shafts, the value we acquire at the top plus the value at the bottom must equal the sum of the value at 3 o'clock and the value at 9 o'clock. So we had 0 at 12 o'clock and 30 at 6 o'clock. We had 5 at 3 o'clock and 25 at 9 o'clock. So top plus bottom must equal side plus side. The power of the validity rule is that we don't have to rotate a full 360 degrees in order to get accurate alignment information. That can come in very handy if we have obstructions. For example, with a lot of small machines, it's impossible to get a reading at 6 o'clock. We only have to rotate 180 degrees and take just 3 readings, since if we know 3 of the values, we can always calculate the 4th value. Whether you're using dial indicators or a laser alignment system, this rule still applies. The validity rule is also the basis of a powerful measurement concept that Viberline has pioneered, which we call true position sensing. I already have the indicators at 12 o'clock. They've been zeroed. So I'm going to roll it down to 6 o'clock. And remember, we had 30 mils. I'm going to roll the dial halfway back to 0 or to 15. Now our dial is reading true position. Now if I roll the dial back to 12 o'clock, do you think it'll still read 0? Well, let's see. No, it reads 15 mils. Since I set the value to 15 mils at a 6 o'clock position, it also reads the true position at the 12 o'clock position. 15 mils at the bottom, 15 mils at the top. The really cool thing is that regardless of where I have the shafts rotated now, I'm always reading true position. So now if I rotate the dial to 3 o'clock, what do you think the indicator will read? Well, let's see. $10 mils, which is half of the TIR value that we got from before. Wherever we have the shafts rotated now, we're always reading true position. So what happens if I roll it to 9 o'clock? You're right. Since we're reading true position, it still reads 10 mils. So as I've just demonstrated, you can zero the indicators at any position, roll it 180 degrees, half the value, and you will then be reading true position. Regardless of the orientation of the indicators, you'll be reading true position in that direction. So can you see how true position sensing can apply to your world? Even if you have an obstruction at 6 o'clock and you can't obtain a reading down there, you can still start at 3 or 9 and obtain true position values. In our next video, I'll show you how to take advantage of true position sensing. That means less measuring and less loosening and tightening of the bolts. It makes the process much more efficient. I'm Patrick from Fiberline. Thank you for watching this video, and please check out our other videos as we're out to realign America.